In this video, we'll be exploring one of the core concepts that's associated with lean thinking and the Kaizen event, and that's visually identifiable wastes, known as lean wastes. The specific learning objectives for this video are to introduce you to some of the thought leaders associated with lean thinking and waste identification, to review the 8 waste category types that are associated with the mnemonic TIMWOODS, and then provide examples of each of the waste types, and to provide some applied tips on how to go about identifying different types of visually identifiable waste. All right, I'm taking a look at some of the workbook material that's included in the program Business Process Improvement using Lean Six Sigma. And what I'd like to first take a look at, tell you a little story about these 3 Lean Six Sigma thought leaders and how they're related to these 8 set of visually identifiable wastes that many people affectionately call Tim Woods. So let's get started with the story. All right, the first Lean Six Sigma thought leader that I want to take a look at is this fellow right here. His name, Taiichi Ono. Ono was an industrial engineer at Toyota and credited with the person who came up with these 8 waste category types. Commonly seen visual waste that occurs, well, my examples are going to be in production and manufacturing environments, but in a moment we'll see how these waste category types, they occur in all types of process-related work, whether it's production, manufacturing, service, back office, software, heck, even legal environments, these wastes occur. And let's explore each of the 8 wastes that he identified and give some examples. The first one is transportation waste. And transportation waste is about the excess movement of raw materials that are associated with fulfilling a particular service request or creating a particular product. You know, envision a drone or a little balloon blimp floating above a production environment. And if there was a video camera on that flying device from above, the recorded activities of forklifts moving raw materials from one location to the facility floor to another location and then back to the original location. That's an example of transportation waste. It's very similar to motion waste. Motion waste is about the excess movement of the operator. Think ergonomic issues, think excessive bends, not using gravity-fed systems. Those are examples of operator motion waste. And and here's the interesting thing, though, about both of them. While they are very closely related, what Ono always said is it doesn't matter that you get the waste in the proper category bin. It's the fact that you are having process workers, process improvement team members, give a name to this inefficiency. Each of these waste category types are different types of inefficiency, and by having the people who are doing the work and who are on the process improvement team, by having them give a name to it, once a name has been given, then they can work on prioritizing it, determining whether it's something that should be focused on for future state process improvement. Once you name it, then you can claim it and start to improve it. And so don't argue with the other team members about whether the earlier example with a forklift moving raw materials across the facility, was that a transportation waste because it was moving raw materials, or was it a motion waste because there was an operator on that forklift? Call out the waste, put it in one of the category types, and then move on. By at least calling out the waste, doesn't matter which bin it was in, we can now start to focus on countermeasure solutions to correct that particular waste. So we've got transportation and motion waste covered. Let's take a quick look at inventory waste next. Okay, I've cleaned up my screen here and zoomed in a little bit to give us a little bit more space for drawings. Let's take a look at inventory waste next. Inventory waste is about your buffer materials on hand. The excess materials that you need to satisfy unique customer requests, or the extra material you hold on hand in case of spikes in customer demand. And in some organizations, the amount of buffer material that we have procured and held onto is too much, too big. We've got too much excess material, and if we have too much that isn't being used, that's wasteful. That's cash that's now locked up that can't be used to help fulfill needs of other customers or other groups in the organization. And so we want to reduce that excess buffer material. So one of the ways to look at inventory waste is if you have too much inventory, what do we need to do to reduce the excess inventory that's on hand? But Ono also recognized that if we don't have enough buffer material and we have to turn away customers with their special requests that are probably at higher margins, or we have to turn away customers during a spike in activity or customer request, that's also wasteful, especially if that buffer material is inexpensive buffer material that could be used to satisfy demands. And so not having enough of this buffer material could also be wasteful. Sometimes we have to increase our buffers. And in all of these cases, when we're dealing with buffer material, it's material we're not going to immediately use. So that means we're going to have to store it. And he said, always take a look at the inventory storage areas that you're using to hold this buffer material. Typically, it's multi-use space that becomes disorganized and cluttered. And when you have the material on hand and the right amount of that material, but you can't find it because of a disorganized inventory storage area, that's also wasteful. So take a look at whether you have too much, too little, and the space that's being used to hold that inventory waste. We've now covered transportation waste, excess movement of raw materials. We've also taken a look at inventory wastes and the buffers associated with them to make sure that they're of the right size and that the space that's being used to hold this buffer is not disorganized. We've taken a look at motion waste related to operator movement. Let's now take a look at waiting waste. Waiting waste is about bottlenecks. Bottlenecks are steps in the system that are slower than all of the other steps up and downstream. And it's about managing to those bottlenecks. Sometimes speeding up a bottleneck, other times realizing that a bottleneck is in place because it is a very value-added step, and making sure that the activities above and below the bottleneck are matched to an equal pace to the bottleneck itself. Waiting waste is not so much about the white space in the system. In earlier videos, we talked about how white space or idle time handoffs in between major activity steps across different departments can be very frustrating and time consuming. This is a little bit less about white space. For lean waste identification, we're talking about processes that are contained within one work group area. And since they aren't being passed across other work groups, a little less about white space, much more about bottleneck management. The next waste that I want to take a look at are two that sound very similar, overproduction and overprocessing, but they're a little bit different. Let's take a look at each. Overproduction is about building more units than what our customer demand is asking for. The old cliche, if we build it, they will eventually buy it, that may be appropriate in the early 20s and forward in the Model T, but in today's day and age, we want to match production to the demands that our customers are making. So understand what your customer demands are, understand what those forecasts are, and then match production to it. If we build more units than what's needed and that sits around and never does get purchased, that's wasteful. Overproduction waste. Overprocessing waste sounds similar, but it's a little bit different. It's about more features in a unit than what is required. What I mean by more features is sometimes I call it the gold plating or over engineering effect, where we put more capability, um, more functionality into a particular product or service request than what our customer demands need. We want to build solutions that satisfy those needs, and if we build too much extra capability in, that's wasteful. That could have been we could have created a product that was less expensive. We could have fulfilled that service request in a quicker amount of time. Over processing or putting more features into a product than what our customer needs are wasteful. There's just a couple more wastes left. Let's take a look at those last two next. Defect waste is about the phenomena where as we're building a product or subcomponent and the product doesn't meet the needs of our customer and we have to throw that product away, literally in the trash, it's an example of a defect waste. In many organizations, though, we do these inspections before we release the product to the customer to make sure that they aren't frustrated by a defective product. And so, but if we do catch a mistake before it hits the customer, we'll often send it back for further rework. So sometimes we're actually counting the number of defects, or in a rework situation, we are measuring the amount of excess time and resources it took to provide that rework. The eighth waste he added a bit later, and it's about staff skill underutilization. And the idea behind this is not developing the skills of the process workers and people associated with the process activities is wasteful. We want to continue to provide new capabilities, new skills for our process workers. Part of staff skill underutilization is around effective professional development. But another part of staff skill underutilization is when we assign a mundane task to a highly trained process worker. So what I'm really talking about here is removal of the mundane or using automation tools and techniques to eliminate or reduce the amount of mundane process work activity that we have. Let's summarize now what we've covered. If we take a look at each of the 8 wastes and grab the first letter from each of the waste category types, there is a simple mnemonic that we can use to remember the 8 wastes. It's called TIMWOODS. But who are the other 2 thought leaders in the photo? We've talked about Ono and his involvement in the creation of TIMWOODS and the 8 category wastes. Um, The other fellow in black and white is a colleague of his from Toyota. His name is Shigeo Shingo. Shingo is responsible for the rapid process improvement project management approach we call a Kaizen event. Ono came up with lean waste identification, and Shingo said, I'll take these concepts and create a methodology in which process improvement team members can rapidly, in 5 days or less, do a process improvement project around the identification and reduction of these wastes. The third thought leader here The third thought leader here in color is a fellow by the name of Jim Womack. He was an MIT scholar that in the late 80s, early 90s, he went over to Japan, observed the activities that were happening at the Toyota facilities, came back to the US and wrote a book called The Machine That Changed the World, the story of the Toyota production system. And I'm not sure if this part of the story is completely accurate or not, but as the story goes, he got a little bit of pressure from his publisher that he needed to create a more generic title name that didn't reference Toyota. He went back and brainstormed with some of his fellow colleagues and coined the term lean thinking, retitled the book, The Machine That Changed the World, The Story of Lean Production, and it became a national bestseller and really brought to light the techniques and concepts that had been worked on for decades over in Japan. The three together are thought leaders associated with lean thinking and lean waste identification.